Welcome to This Explainer. Today, we're tackling a massive hurdle that pretty much everyone faces when they first start using AI for software development. We're looking at a totally crucial scoping rule from Triona, all about AI code generation. It's called, simply, generate in small units. Now, if you've ever found yourself staring at a completely broken AI-generated code base, sitting there wondering, man, would it have just been faster to write this myself from scratch? Well, you are in the exact right place. We're going to unpack exactly how you can escape that trap and basically take back control of your code.
Okay, let's dive into this. It is incredibly tempting, right? I mean, you've got this amazingly powerful tool like ChatGPT sitting right there, and you just think, you know what? I'll just tell it to build my entire app. It feels like absolute magic. But why does that magic so often turn into just a total debugging nightmare? The source material we're looking at today hits on a really universal pain point. When you ask an AI to generate a huge code base all at once, you're basically setting yourself up to hit an opaque wall of code. So let's look at exactly why this happens, and more importantly, how we can structurally avoid it.
So that brings us to section 1, the mega prompt mistake, escaping the tangled blob debugging spiral.
And this brilliantly illustrates the core problem. The mega request is the classic trap. You ask for the whole app at once, and the AI spits out hundreds of lines of code. But here's the fundamental issue, right? One single hidden bug, or just one bad assumption made early on by the AI, taints absolutely everything that follows it. It is literally a house of cards. The alternative here is generating in small units. By asking for just one function or one module at a time, any bugs that do pop up stay completely isolated and manageable. The source text makes a really profound point about this. A giant generation? Sure, it's visually impressive, but it's fundamentally unverifiable. When an AI hands you 300 lines of code, you simply cannot easily tell which specific line is subtly broken. And because code is, deeply interconnected, a single bad assumption early on spreads everywhere throughout that massive output like wildfire. So instead of saving time, you end up getting dragged into what Triona calls a tangled blob debugging spiral. You're stuck spending hours untangling a massive mess that you didn't even write in the first place.
Moving on to section 2, the small unit solution. Verifiable code, one piece at a time. Now, what's really interesting about this slide is how this primary scoping rule shifts all the control right back to you, the developer, through a beautifully simple workflow. Let's break it down. Step 1. Ask the AI to generate just one single piece. That could be a function, a component, or a module. Step 2. Verify and test that piece. Seriously, do not move forward until you know it works. And step 3. Only then do you request the next piece. It totally transforms the AI from this chaotic magic wand into a precise, highly manageable engineering tool.
Think about it. Why hunt through 1,000 lines when you can check 20? This approach works because small units you can actually verify are always going to be one giant blob you can't. When you keep each piece within a scope that you can actually read, understand, and test, you maintain absolute authority over your code base. If the AI makes a mistake, and let's be honest here, it absolutely will, that error stays isolated to a tiny 20-line function. It is cheap, it's fast, and it's incredibly easy to fix right then and there.
Let's ground this whole concept with a practical example directly from our source. Say you want to build a to-do app. The huge mistake is just going in and commanding, hey, build a to-do app. The small unit solution is to break that right down. First, you ask the AI to generate just the data model. You verify it. Next, you ask for the store. You verify it. Then you generate one UI component at a time, verifying each and every one. By the time you're done, you actually have a fully functioning app, and you never once had to reverse engineer some massive AI-generated hallucination. Which brings us to section 3, the perfect AI coding prompt, the golden template for execution.
So the crucial point is this exact copy-pastable prompt provided by Triona to enforce this workflow. It goes exactly like this. We're building this feature, let's go one piece at a time. Start with just the first unit, its signature, implementation, and a test. I'll confirm it works, then we'll do the next piece. Notice how explicitly this sets boundaries for the AI. By demanding the signature, the implementation, and a test for just the very first unit, you are rigidly enforcing verification right from the jump.
But look, even with the absolute perfect prompt, human discipline is still the real bottleneck here. The first pitfall, as we've talked about, is falling back into that old, lazy habit of prompting build the whole thing and then ending up staring at an opaque wall of code. The second major mistake, and this is a big one, is moving on to the next piece before the current one is strictly verified. If you skip that test phase, the whole system breaks down.
And third is losing the thread of how the pieces actually connect, which usually happens specifically because you skipped reviewing those components in isolation. Human discipline is absolutely key here. Let's move to and see how this builds into Section 4, when to break the rules, the boilerplate exception. Now, to be fair, this scoping rule isn't an absolute, unbreakable law for every single keystroke. For any non-trivial builds, the bigger and more interconnected the feature is, the more it pays off to slice it up and test it individually. However, for genuinely boilerplate scaffolding, stuff like a standard config file or just a basic CRUD stub that's highly predictable and super low risk, for that kind of stuff, it is perfectly fine to let the AI generate those predictable chunks all at once. Basically, just use your best judgment based on the complexity of the actual task. As we wrap up this explainer, I want to leave you with this final, kind of provocative thought to consider for your next project. When you open up your AI tool, are you delegating blindly, just crossing your fingers and hoping for a magic mega prompt to do your job for you? Or are you engineering verifiable code together, piece by piece? Embracing this small unit approach completely transforms the AI from an unpredictable oracle into a collaborative, highly effective engineering partner. Seriously, try out that step-by-step prompt we discussed today and see how it completely changes your workflow. Thanks for joining me on this explainer, and happy coding!